Hi everybody, welcome back. We are ready for lesson 4-2. Are you doing bunny ears behind me?
I'm not.
Okay.
Now I am.
We're going to talk about the trig functions of acute angles. Okay, so here's your learning targets. We'll let you read those on your own. But
I'll be back later.
He'll be back. Basically, he's really not going anywhere. He's going to sit over there and catcall me from the side. Basically, what we're going to do is we're going to take our angles and we're going to put them inside of triangles, and specifically inside of right triangles. So we all like right triangles in geometry. So the three basic trig ratios that you should already know are the sine of the angle, the cosine of the angle, and the tangent of the angle, otherwise known as
SOHCAHTOA.
SOHCAHTOA. You know, and when I was in high school, we learned it as CAHSOTO, and then people go, bless you. But
That's just weird.
anyway,
I
it is
learned
pretty
it as
weird.
so on Halloween, Cat and Hippo took over as Manta.
And you still remember it. How many years ago was that?
A long time ago.
Okay, one really, really important thing about the ratios of these triangles. They're used on an acute angle, which means you may never, never, never write sine or cosine or tangent without an angle after it. For right now, we're probably going to have a theta after it. Okay, we need to go a step further because this is pre-calculus, so we need to stretch you a little bit. Besides those three ratios, we have the three reciprocal ratios. So we have the cosecant, we have the secant, and we have the cotangent. Okay, so these are new. Pay attention. Cotangent. Okay, so here are their abbreviations. The cosecant is abbreviated CSC. That was really easy for me because my college was Chadron State College, CSC.
How about Colorado Springs, Colorado?
Colorado Springs, Colorado is beautiful. Okay, we're going to use that again later with Colorado Springs. Okay, the secant is abbreviated SEC, and of course the cotangent is abbreviated COT. But just as there's no sinning in math, there's also no cots in math till later, next chapter. Okay, so the reciprocal of the sine is the cosecant, and the reciprocal of the cosine is the secant, and the tangent's pretty obvious here. Now, since it's a reciprocal, instead of thinking of this as 1 over the sine, sine was really what?
Opposite over hypotenuse.
So if we flip that over, we would have
Hypotenuse over opposite.
very nice. So you can think of it that way as well. Okay, so in your brain, you're remembering reciprocal, but when you go to work out the problems, you don't always need to write 1 over. Okay, so the secant is the reciprocal of the cosine. Cosine was?
Adjacent over hypotenuse.
So the reciprocal would be?
Height over edge.
Very nice. We just write the abbreviations and we don't say them.
Hypotenuse over adjacent.
And then the cotangent of theta would be?
Well, tangent was sine.
Was opposite.
Over adjacent.
Over adjacent.
So adjacent over opposite.
Adjacent over opposite. He almost spoiled a surprise that's later to come.
Sorry.
Okay, fast forward. We're ready for the first example. Notice we have an acute angle inside of a right triangle. Everything refers back to theta. So if you need to, go back to the fact that this is the hypotenuse, and this is the adjacent, that's the one that touches it, that's not the hypotenuse, and this is the opposite. But notice,
we don't have the opposite
we don't
side.
have the opposite side, so we need to find the opposite side. What do we know about the sides of a right triangle?
A squared plus B squared equals C squared.
Yes, it does. So a squared plus 21 squared equals 29 squared. If you don't know how to do that, come see us. What'd you get for A, Mr. Lucky?
I got 20.
I did too.
That's good.
Okay, so our three sides of our triangle are 20, are 20, 21, and 29. We're ready to write our ratios. Find all six.
We're going to do all 6 of them?
All 6 of them. Let's start with SOHCAHTOA because that's easy.
Sine.
So the sine. So I can just write sine, right?
No.
No. Sine of theta equals
Opposite.
20.
Which is 20 over hypotenuse. 29.
Okay, cosine.
Cosine is adjacent over hypotenuse. So that is 21 over 29.
Very good. And tangent won't fit up there.
Tangent is opposite over adjacent, which is 20 over 21.
20 over 21. Now all we have to do is go do the reciprocals. We do,
What's
however,
reciprocal mean again?
flip it over.
Awesome.
We also need to remember which reciprocal goes with which. Now here's my cheater method of this. Notice that sine and cosine has the co, right? So secant and cosecant has the co. You would think the co goes with the co, but it doesn't. They're backwards. So the sine is really the cosecant, the reciprocal rather, of the cosecant. And the cosine's reciprocal is really the secant.
I just remember that the S and the C have to be opposites.
That works too. I like the co part because it's co-field, you know.
Oh, yeah.
So this would be 29 over 20.
That's cheating.
Flip it over. 29 over 21.
Flip it over.
And then we have the cotangent of theta would be?
21 over 20.
Bam. You're done, and your arm hurts because you wrote a lot. Okay, we got to take this up a notch. That was a little too easy.
This is
Next
like
question.
Cooking channel.
I know.
Bam.
Next question.
Take it up a notch. Where's Emerald?
All right, we are given that the tangent of theta is 5 over 12. We need to find all the other trig ratios.
I didn't lose them.
Okay, so this must be in what triangle again?
A right triangle.
A right triangle. Okay, how do I get my fancy right triangle? Is this it?
Just draw one.
I could do that too, but I want to use your fancy board here.
There you go. Now
Okay.
draw a triangle.
Do I put this down?
Yep.
Okay,
Now push the button down on the marker where you're going to draw triangles. There you go.
okay. You draw triangles everywhere. So here's my triangle. Let's make a theta. Do we really care where theta is? No,
Well,
pick
it
a
needs
theta.
to be inside the triangle.
It does, and it needs to be not the 90, okay? Now, we know that the tangent of theta is 5 over 12. What was the tangent ratio again? It was opposite over adjacent.
OA.
So the opposite side is 5, the adjacent side is 12. Go ahead
Does
and
that
work
mean
out.
we have to solve for the hypotenuse?
We do have to solve for the hypotenuse, or if you know your Pythagorean triples,
That's 13.
that's 13. If you don't know how we got that, try 5 squared plus 12 squared, and then take the square root. We're not going to take video to do that. Okay, so now that we have all of our stuff,
We do SOHCAHTOA again.
we can do SOHCAHTOA, except for tangent's already done.
All right.
Okay, so I'm going to go ahead and do the cotangent ratio, because that's going to be the reciprocal of the one they already gave us, which is 12 over 5. Okay, and now we can go ahead and do our sine and our cosine, because those are familiar. Cosine of theta. Okay, sine,
5/13.
5
Opposite over hypotenuse.
opposite over hypotenuse.
Cosine
Cosine?
is adjacent, which is 12 over 13.
Very good. And then our reciprocals again, flip them over. This was an S, this one's a C. Cosecant,
13/5.
13/5. Is that
That's
okay?
all I
Those
have
are.
to do is just flip it over?
That's all you got to do is flip it over. Notice that's more than 1, and that's okay. We'll talk about that later. Okay, secant of theta would be
13/12.
13/12. Pretty easy, right? The hardest part is that you need to start with the picture.
Piece of cake.
Okay, there are some special triangles we need to talk about, and Mr. Lucky's going to help you with that.
They're very special.
Very special.
But you better memorize them, or at least how we get them. All right, 2 triangles. You've done these in geometry, whether you remember or not. Now we're about to find out. 45, 45, 90 is called that because we have a triangle that has AC over here is 1. That means in our, what is it, our angle A is 45? So if A is 45, what's angle B?
45.
That's right, because they have to all add up to?
180.
There we go. And if we have 2 angles that are both 45,
Then it's isosceles.
and their opposite sides are the same, so this is also 1.
Very good.
How do we get the hypotenuse?
A squared plus B squared equals C squared.
And if we do 1 squared plus 1 squared equals C squared, what does C equal?
The square root of 2.
Awesome.
I can't believe you made me do that in my head.
You can add 1 together twice. Okay. Where are we going for this? Solve for the remaining parts of the triangle. I think we did that.
We did that.
We found B, we found A, we found all the 3 sides. So we have solved all the parts of the triangle. Now we'd like to find sine, cosine, and tangent. I guess I didn't need that much room. Okay, so which angle do we want to pick?
Sine.
Angle.
45. Says
Which
45.
which 45?
Oh, it does. B.
Does it really matter?
No, they're the same.
All right, so we're going to do sine of 45. And again, we're just going to use our opposite, adjacent, and hypotenuse things. What's the
1
sine?
over the square root of 2.
1 over the square root of 2.
Mr. Lucky, do we have to rationalize the denominator?
You don't have to,
Yay.
but you should recognize it.
Oh, okay.
So real quick, just for fun, so we can say we've done it once. How do we rationalize this denominator?
Multiply by the square root of 2.
We do that on the bottom and the top. That gives us 1 times the square root of 2 is the square root of 2, and the square root of 2 times the square root of 2 is 2. So what you need to be aware of is those 2 numbers are exactly the same.
Hey, that looks like that stuff we did in FST.
Yep. It's exactly like the stuff you did in FST. How about the cosine of 45 degrees?
Cosine's adjacent over hypotenuse. 1 over the square root of 2.
But that's the same thing.
That's okay because they're both a 45-degree angle.
That's pretty cool. How about tangent of 45 degrees?
Let's see, that would be opposite over adjacent. That's 1.
It's 1 over 1, which is just 1. All right, what are we supposed to do with those 3 things?
We're supposed to memorize them.
All of them?
That's what it said, all 3 of them. But
Every
sine
one
and
of them.
cosine are the same.
That's right. So for a 45, 45, 90 triangle, we have, or from that triangle, we have the sine of 45 and the cosine of 45 are both 1 over square root of 2, and the tangent of 45 degrees is 1. Memorize it.
Or memorize the picture.
Okay, second triangle, 30, 60, 90. All right, we got to memorize this one too. But it says triangle ABC is equilateral. What's that mean?
All the sides are the same.
All the sides are the same. So this side's that side, that side are the same, but that means all the angles are equal to what?
60 degrees.
60 degrees. Well,
That is
that's a,
180 divided by 3.
well, that's a 60, 60, 60 triangle then.
Well, then something's wrong because we didn't have the right triangle.
Okay, well, hold on. Let's keep reading.
Okay.
It says draw the altitude. Altitude's another word for height. From A to BC. Well, here's A. I got to go down to BC. So if I draw the altitude, a couple cool things happen. Number one, it bisects this angle. So that 60-degree angle is now what?
30.
30 degrees. Oh, and by the way, I was supposed to label this D according to my directions. Okay?
The altitude also makes it perpendicular.
It also makes it perpendicular. Is that true every time?
Yes, that's the definition of an altitude.
That's right. But it doesn't always break the angle in the top. But it does for this triangle.
Because it was equilateral.
That's right. BAD, angle bad.
30 degrees.
BAD was 30 degrees. All right. What kind of triangle do we have on that left side then?
30, 60, 90.
There's my 30, 60, 90 triangle. That's where the name of the title of this section, or whatever we want to call it, comes from. We okay with that?
We're ready.
All right. Now it says suppose AB equals 2. All right, fine. AB is 2. So AC is 2. And BC from here to here is 2.
Does that mean BD is 1?
Yep, because that altitude not only chopped the angles in half, made a 90-degree angle, it also chopped the side in half of AC. All because it was equilateral and really isosceles, but hey. So what's the third side? What are we going to call it? Let's call it B. How's that?
Okay.
So we have 1 squared plus B squared equals 2 squared.
How'd you get that?
That was the Pythagorean theorem.
Oh, yeah, that's right.
1 squared is 1. 2 squared is 4. Subtract the 1, we get B squared equals 3, or B is equal to the square root of 3.
I agree.
All right, so we now know that this little triangle right here is the square root of 3 high. Is that okay?
Yes.
All right, have we solved for all the remaining parts?
I think we have, but we might want to redraw that.
We will.
Okay.
Let's do it here. You ready?
Yeah.
We have our 30, 60, 90 triangle. We had 60 degrees here. We had 30 degrees here. We had 1, 2, and square root of 3. Is that what we had?
Yes.
All right, so you need to memorize that triangle. Or memorize the answers to what we're about to do. We want sine, cosine, and tangent of 30 and 60. I think on your paper you have a dotted line down the middle. So let's do sine of 30, cosine of 30, and tangent of 30. Well, here's our 30-degree angle. What's the sine of 30 degrees?
Sine is opposite over hypotenuse, so 1 over 2.
1/2. Cosine of 30?
That must be a square root of 3 over 2.
Adjacent over hypotenuse. And tangent of 30?
Opposite over adjacent, 1 over square root of 3.
That was easy enough. How about we do the sine, cosine, and tangent of 60 degrees?
Does it really matter?
Let's
Isn't
find
the
out.
30 and the 60 the same?
If you had $60, you had $30, are those the same thing?
Nobody likes us smart. Yes.
Let's try it.
So basically the hypotenuse is the same, but now the opposite and adjacent has
That's right.
switched.
This is now opposite, and the hypotenuse is still here, but you're right.
Okay. Sine of 60.
Wasn't sure where you were going with that question. Sine of 60 is opposite over adjacent, or opposite over hypotenuse, which is square root of 3 over 2. What's the cosine of 60?
1 over 2. Adjacent over hypotenuse.
And the tangent of 60?
Opposite over adjacent, square root of 3 over 1.
All right, which is just the square root of 3. Is that
Correct.
okay? All right, what are you supposed to do with those 6 things?
Memorize them.
Memorize them. You sure?
Memorize them. Or
They're-
remember the triangle.
You either memorize the triangle or memorize those 6 things, but you must memorize all of them. And if you don't, how hard is the rest of this chapter going to be?
Really hard.
Really, really, really hard. Okay, let's continue. We got a word problem here. Mrs. Cofield wrote it, so I'm going to let her do it.
Yeah, but you need this because you got to give me all the answers.
Okay.
Okay. So we have a ladder.
I have wrong answers.
Oh. We have a ladder. It's going to be extended to reach the top floor of an 84-foot tall building. Okay? And the building's on fire. So let me get a little building over here. And here's my little fire truck. No making fun of my pictures. It's a pretty bad fire truck, but you get the idea. Okay? There's its ladder. Little siren on top. Okay. Fire, 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 fire. I should make it red. Fire, fire, fire.
Welcome
Okay.
to Art Class 101.
And there's a little window here, okay? The building is 84 feet tall. Okay, this is what we know so far, yes? Let's keep reading. The firefighter sees someone who needs rescuing. Oh gosh. Now I gotta draw a person. Help!
We're not the only ones needing help.
Okay, so here's my person, and they're sticking their head out of a window, but the window is 8 feet below the roof of the building. Okay? So really quickly, how far off the ground is the person?
Whatever 84 minus 8 is. How about 76?
76 feet tall. Okay, so how far should the ladder be extended to reach? Now, the question says the roof of the building, but some crazy lady typed this and she was in a hurry. It's not really the roof of the building. It's the window, because that would be where the person is that we need to rescue. So change your notes to say window right there. If the ladder must be placed at the optimum operating angle of
60 degrees.
60 degrees.
Did
So
you
I
look
need
that
to
up?
put a ladder. I have a firefighter friend who told me. I need to put a ladder right here. Well, if you put it too steep, they fall off.
Probably.
All right. This is a 60-degree angle. This side is 76. And the question was, how far should the ladder be extended? So am I looking for the adjacent here? We're going to assume the building's at a right angle to the ground. Do I want the adjacent or do I want the length of the ladder?
I want the length of the ladder.
Yes, you do. I'm going to call it X.
So that's the hypotenuse.
That's the hypotenuse. Okay, so if this is my 60-degree angle, and this is my 76 side right here, is that opposite or adjacent?
Well, it's opposite your 60 degrees.
Okay, so I'm dealing with the opposite, and I'm dealing with the hypotenuse, which means I'm going to use,
Sine.
yes.
Sine is opposite over hypotenuse.
Okay, sine of what? Because I always have to have something right there.
Well, we used theta before, but how about 60 degrees?
Yes, because we know the angle is 60 degrees. So the sine of this 60-degree angle is going to be opposite, 76, over
X.
X, because we don't know that length. Okay, so let's go ahead and get the X by itself first, okay? So we're going to times by X. We're going to times by X.
They always forget to do that.
We're going to get the X. That's okay. I'm going to show you a shortcut. X sine 60 equals 76. Then we're going to divide by the sine of 60. Divide. I'm only going to show this once, so sine of 60. Okay, so basically, didn't the X and the sine just switch places?
Yeah.
That's your shortcut right there, okay?
Okay.
But what is the sine of 60?
Well, it's the square root of 3 over 2.
Okay, so if I have the square root of 3 over 2, how do I do a whole number divided by a fraction?
You multiply by the reciprocals, but everybody at this school is going to say copy dot flip.
Yes.
I don't know where that came from.
I don't know. I'm blaming Mrs. Jubelhauer because I think that's where I heard it from. Okay,
76 times 2 is 152.
so we have 152
And a really weird board.
divided by the square root of 3
Can we leave it that way?
feet. Well, it depends on if I have a calculator or not. If this was a no calculator question, you would stop right there. You have 152 divided by the square root of 3
If I had a
feet.
calculator, could I just type in 76 over sine of 60?
Yes, if you had a calculator, you could type in 76 over sine of 60. And we're going to practice both of those next class, doing it with and without a calculator. Alrighty?
I think that'll do it.
I think that'll about do it. So, looks like that's it for our notes. So,
Bye.
memorize your triangles.
Yeah, what she
And
said.
we'll see you next time. Bye.